Good day. This is a short presentation of our paper Method for Appropriating the Brief Implicit Association Test to Elicit Biases in Users, published at SIGCHI 22. My name is Tilman Dingler, and I am presenting this work on behalf of my co-authors Benjamin Tag, David Eccles, Niels from Berkel, and Vassilis Kostakos. So, media companies and their practices have recently come under quite some scrutiny for the creation of echo chambers, the fallout from micro-targeting, and practices to keep users' attention at all costs. For years, the study of context-aware systems has been central to our HCI community, but for systems to adapt to the user's context, they also need to know about cognitive processes, such as what we pay attention to and why, how we filter information in the vast information space, and what makes us receptive to certain information. And this is where cognitive biases come into play. Cognitive biases are a set of heuristics learned over time that serve as shortcuts to effectively navigate dense or complex information spaces. And these biases, they play an important role in how information is perceived and processed. And so systems influence that perception through their content, their interface, and also their system behavior. So in our work, we study these biases and how computing systems exacerbate or mitigate them. But we need some sort of method to collect ground truth on biases, implicit assumptions, or hidden tendencies. Now, we could simply ask people how they feel about conservative politics or whether they would support affirmative actions in university hiring processes. But the challenge with biases is that they are often implicit, which means people may not be aware of them, or they are aware of them, but they just wouldn't want to tell us. So another approach that was proposed by colleagues in psychology, namely Anthony Greenwald and his team in 1998, is the Implicit Association Test, or IAT. The original IAT measures individual differences of the association of an attribute, for example, a stereotypical name or a face, with a concept, for example, gender or race. This is achieved by tasking users with quickly responding to a matching task of a concept and an attribute. And so the pressure to respond as fast as possible is meant to induce heuristic processing in users rather than in-depth contemplation. The idea is that given certain preferences, tendencies, or plain biases, some concepts are easier to map to certain attributes than others. And so over the last decades, this test has been used to elicit implicit tendencies with regard to topics such as race, gender, and self-esteem, and the word sets have been validated over many years. But a lot of today's issues are more specific, and the conversation around them evolves rather quickly in the public discourse. So we need a method to create tests on contemporary topics as they are emerging, such as pro-life, pro-choice, for example, or gun control, but also for things like Apple versus Android or dark mode versus light mode. So we created a method that would allow us to come up with word sets for custom topics. But we had to avoid our own biases in creating such word sets and at the same time make sure that our target group had strong associations with each word in those sets. The solution we thought of was involving the crowd in a multi-step validation process. So eventually we ended up with a two-step process. First, an initial sourcing of words for the set using multiple researchers and a thesaurus. And second, using Amazon mTurk to invite people to undergo association tests using the new word set and reporting words that have weak, no, or misleading associations, and then make suggestions for replacements for those. And this step we repeated until a high agreement on all words had been reached. To do this, we built a web tool that administers the brief version of the implicit association test, also called BIAT. This is basically a refined tool developed by Schreeram and also Greenwald in 2009, which effectively shortens the IAT. Users of the BIAT are required to remember the objects within two categories. In this example here, we have man-made climate change versus natural climate cycles. And so here on the slide, man-made climate change is the so-called focal, paired with good attributes. So whenever users see a concept that belongs to man-made climate change or is a good attribute, they should press one key, and for all other concepts and bad attributes that are shown, they should press another. The first block is a shortened training run, and then the second block pairs the concept man-made climate change with good attributes in this example. Then for the third block, the pairing is switched and users need to rewire their responses to try and associate natural climate cycles with good attributes on the focal side and all other on the non-focal. From here on, the pairing then alternates until block 5 is reached. And so after all 5 blocks have been administered, the software uses the reaction times to calculate the so-called D-score. When comparing the test block results, the numerical range of D reaches from -2, a strong preference for man-made climate change, to +2, a strong preference for natural climate cycles in this example. We then also gave participants the chance to report their impression on how well this score fits their actual tendencies. That is a subjective assessment. We did this with 3 cohorts of MTOG workers who underwent the BIAT for 4 different topics. Each cohort we asked for feedback on weak, no, or misleading associations and make suggestions for word replacements. In the first round, we used a majority vote to substitute then all ill-fitting concepts, and for the following round, we used Vatavu and Wobrock's agreement score calculation to determine candidates for substitution, namely those where participants were in low to medium agreement. We were planning on actually repeating this procedure until the high to very high agreement score had been reached on all words. In our case, however, high agreement on all words was reached in round 3. We then conducted a final evaluation round with another 50 MTOG workers. At the top here, we can see how participants reported how well the BIAT's D-score fit their own tendencies. And below we can see the correlations between the D-score on the y-axis and the self-assessment on the x-axis. For political leaning, we found a strong, for feminism a moderate, and for climate change a weak correlation between the objective BIAT score and the self-assessment. Finally, we assessed how well our crowdsourced word sets compare to word sets produced by domain experts, that is, accomplished scholars in the fields of politics, climate change, and multiculturalism. Here we can see the resulting word sets, which we then discussed with our experts. And the expert sets were really considered more specific in their meaning and associations, while the crowdsourced sets seemed more general, with more frequent overlaps, often, quote, inspired by conversations on social media. The crowdsourced sets also reflected more stereotypes and seemed to resemble the geographical and temporal dependence of the topic's discourse. So, in order to study the effect of user bias on system usage and vice versa, we present a web tool for ground truth collection on users' implicit tendencies. This tool is seeded with word sets that are created through our 2-step method. And we have shown that the word sets created with this method are target group specific in terms of geography and contemporary discourse language. And so, we release our BIAT tool, open source, for the community to conduct research on cognitive biases and their role in computing systems. For more details, have a look at our paper and feel free to reach out.